Okay, let's have a look at what's called the product rule. And the product rule is used when we're asked to differentiate something that looks like this, where we've got something, and you can see we've got something in brackets here, multiplied by something else. So we got x squared minus 4x multiplied by 3x squared plus 2. So it's not like anything that we've seen before, so we're going to have to come up with a new way to differentiate this. So okay, let's look at this. I'm going to show you two ways to do it using the two different notations. One where we've got where we use dy over dx, and one where we use f dash of x. Now both of them are exactly the same, and I'll do both of them together so you can see how that they're exactly the same, and you can choose which one that you like to use. So the product rule says that if y is equal to uv, so uv means u multiplied by v, so that's what we have up here. We've got something multiplied by something, so this part here is the u part, the x squared minus 4x, and the v part is the 3x squared plus 2. So if y is equal to u times v, which it is, then dy over dx, which is what we're looking for, is equal to v, so this part, times du over dx, and du over dx just means the u part differentiated, plus u, which is this part, multiplied by dv over dx, which is the v part differentiated. And each part here, the x squared minus 4x, that's easy to differentiate by itself. 3x squared plus 2 is easy to differentiate by itself. Okay, then that's the product rule. It's very, very simple to use. In the f of x notation, that looks like this. So rather than saying if y is equal to u times v, we say if f of x is equal to u of x times v of x. So we use the function notation. So this part here would be u of x, and this part here would be v of x. So rather than saying just u and v, we say u of x and v of x. Then f dash x, which is the dy dx part, is equal to v of x, this part, times u dash x. And remember, u dash x just means the u part, this part, differentiated, plus u of x, so this part, times v dash x. So this part differentiated. So those two rules, they're exactly the same. They might seem a little bit complicated at the moment, but when we do an example, they're actually pretty straightforward. They're pretty easy to follow. So let's have a look. Okay, let's have a look at this example. So it's the same sum, and I'm going to do it both ways. I'll do the dy over dx method over here and the other method over here. So I'm going to write down the two rules again. First of all, I'll write the dy over dx method. So it says if y equals u times v, then dy over dx, which is what we want at the end, is equal to v, the v part multiplied by du over dx, plus the u part multiplied by dv over dx. Okay, so in that, we need to know what u is, we need to know what v is, we need to know what du over dx is, and we need to know what dv over dx is. So in a product, the first part of the product is just the u part. So this is u. So I'm going to write down, and I think if you lay it out exactly like I laid out, I think it'll make it a little bit easier for you. So I'm going to write u is equal to the first part, x squared minus 4x. And v is equal to the second part, it's equal to 3x squared plus 2. So v is equal to 3x squared plus 2. Okay. So now we're looking to find dy over dx. This whole thing here is y is equal to. So in order to find dy over dx, I need u, which is that. I've written that down, and I need v, which is that. I also need du over dx, and du over dx just means this differentiated. So here I have u is equal to that. So du over dx will equal. Okay, differentiate this. This is easy to differentiate because it's just a difference, something minus something. So differentiate x squared and I get 2x, and differentiate minus 4x and I get minus 4. So they're just using the x to the power of n and the ax to the power of n rule. Here I've got v is equal to this, so I need dv over dx. So I can differentiate that to find dv over dx. And dv over dx will be, well, here I can use the ax to the power of n rule, so 2 by 3 is 6x, and then differentiate a constant, differentiate plus 2, I get 0. So now I have everything that I need. So dy over dx, so dy over dx will equal, it's v, so v is this, so 3x squared plus 2 times du over dx, so times 2x minus 4. plus u, which is this. So plus x squared minus 4x, x squared minus 4x times dv over dx, so times 6x. And I can tidy this up by multiplying it out and then adding up any like terms. So I'll do that very quickly. So I have dy over dx is equal to, so it's this bracket by this bracket plus this bracket by this bracket. So 3x squared by 2x would give me 6x cubed. 3x, yes. 3x squared by minus 4 would give me minus 12x squared. 2 by 2x plus 4x. And then 2 by minus 4 is minus 8. Plus, I've got x squared, now these brackets, x squared by 6x plus 6x cubed, and minus 4x by 6x is minus 24x squared. And I can just add up any like terms there. So I have dy over dx, adding up like terms, I've got 6x cubed plus 6x cubed, that gives me 12x cubed. I have minus 12x squared minus 24x squared, so that's minus 36x squared. And I have, I think that's it, is everything I can add up. 1, 2, 3, 4. I got 4x, so plus 4x, and then minus 8. So this is dy over dx. So going back to the start, so we are asked to differentiate this. It's a product. I've got the u part, I've got the v part. Then if y is equal to u times v, which it is, it's u times v, dy over dx is v by du over dx plus u by dv over dx. So the u part is this. That means that the u over dx part is this. The v part is this. That means that dv over dx part is that. And that means dy over dx is this by this plus this by this, which simplifies down to that. All very simple. I hope you can get it. You might have to watch this a few times before you get it. Okay, let's have a look at, we'll do the same question, but we're going to use this time the f of x notation. So let's first of all write down the product rule using function notation. So the product rule in the f of x notation says that if f of x, which is this whole thing up here, is equal to u of x times v of x, then f dash of x, which is what we're looking to get, is equal to, it's, what way did I write it before? It's, if you look here, it's v of x times u dash x. So v of x times u dash x plus u of x times v dash x. Okay, so all we need to do in order to do this question is figure out what is u of x and what is v of x. So u of x is the first part, so it's like the u part over here. So I can write down u of x is equal to x squared minus 4x, and v of x is the other part of the product. So it's 3x squared plus 2. I've got u of x here, so I can find, by differentiating that, u dash x. And differentiate x squared minus 4x, I get 2x minus 4, the same as over here. But I called it du over dx here. Here I can get v dash x. And when I differentiate this, I get 6x. I differentiate 2, I get 0, so that's the same as over here. And now to fill it into this, f dash x is equal to, well, it's equal to v of x, so this part, 3x squared plus 2. And you'll notice what I write down here will be the exact same as here. So it's 3x squared plus 2 times u dash x, which is that. So times 2x minus 4 plus u of x, which is this part, x squared minus 4x, times v dash x, so times 6x. And so this line is exactly the same as this line here. When I multiply it out, I end up with f dash x is equal to, and I get the same thing here, it'll be 12x cubed minus 36x squared. This is just multiplying it all out, plus 4x minus 8. So it's exactly the same as over here. So there's two methods, the dy over dx method and the f dash x method. So you can choose which one you like. I kind of prefer the f dash x or the f of x method. I just think it's, I don't know, it's just a nicer way to write it, but it doesn't matter which method you use. So let's have a look at another question where we got to use the product rule. And I'm going to do it quickly. I'm going to do it using both methods again. So this time we're asked to differentiate this. 2x plus 4 multiplied by the square root of x. Okay, and remember before when we had the square root of x, first thing we'll do is we'll write this as x to the power of a half. Okay, but before we do that, we've got a product. We've got this multiplied by this. So, okay, let's use the, so we're going to, well, let's write y is equal to, so it's 2x plus 4 times the square root of x. So if y is equal to that, then the u part is the first part, so it's 2x plus 4. The v part is the square root of x. Here I can find du over dx and differentiate that, and I just get 2x I get 2, differentiate 4 I get 0. Here, before now, be careful here, but because before I differentiate the square root of x, remember to differentiate a square root, you write it first of all as x to the power of a half. Now I can find dv over dx. I can differentiate and I get a half x to the power of minus a half. So then dy over dx by the product rule, dy over dx is equal to, okay, let's write out the product rule. First of all, it is v times du over dx. So this by this plus u, this 2x plus 4 times dv over dx. Oops, I didn't mean to write that. I should have written times, wait, hang on, I'm writing the product rule. So times u, sorry, v by du dx plus u times dv over dx. Now I can fill it in. It's a bit of a mess there, but it doesn't matter. So I have dy over dx is v by du dx, so the square root of x, oof, I'm making a mess of everything here. So the square root of x times, so v by du dx times 2 plus u, 2x plus 4, times dv over dx, which is this part here, so times a half x to the power of minus a half. And that's the answer. We can leave it up. We could tidy it up a little bit. I'm going to leave it for the moment. You can tidy this up yourself. You know what to the power of minus a half means. So you should be able to tidy this up yourself. Okay, let's do the same question. Let's use the f of x method. So I'm going to start off by writing, I'm going to say that f of x, so f of x is equal to this. So f of x is 2x plus 4 times the square root of x. We've got a product, 2x plus 4 multiplied by that. So u of x will be the first part. So u of x is equal to 2x plus 4. And v of x is the other part, is the square root of x. Here I can find u dash x, just differentiate. So that will give me 2, same as over here. Here I can find v dash x, which would be, well, before I differentiate, before I write, work out v dash x, I should have written this as, okay, that's the same as x to the power of a half. So now differentiate x to the power of a half. So when I differentiate that, I get a half x to the power of minus a half. And then f dash x, well, by the, let's write down the this rule. So f dash x is equal to v. So v of x times u dash x plus u of x, u times v dash x. So let's fill it in. So f dash x is equal to v of x. So it's x to the power of a half, or the square root of x, multiplied by u dash x, so multiplied by 2, plus u of x, which is 2x plus 4 times v dash x, which is this, a half x to the power of minus a half, x to the power of minus 1 over 2, and this is your answer. We have it down to here. Okay, let's while we're at it, we may as well just tidy it up a little bit. So root x by 2 is 2 root x. And then we have, okay, we've got 2x plus 4. So we've got a half x to the power of minus a half. Remember what to the power of minus a half means? It just means 1 over to the power of a half. So we've got a half. And then this x to the power of minus a half is the same as 1 over x to the power of a half, which is really 1 over the square root of x. So x, let's write it up here, x to the power of minus 1 over 2 is equal to 1 over the square root of x, which is what I've done there. So I have, okay, I've got 2 the square root of x plus, I've got to multiply all of these. So really, I can put this over 1. Now I've got 3 fractions, top by top by top, bottom by bottom by bottom. So I've got 2x plus 4 by 1 by 1. So that's going to be 2x plus 4 on top. And I've got 1 by 2 by root x. That's going to be 2 the square root of x here. So this and this line are the same, and all I did over here was I tidied this up a little bit, and I got down to here, so I could do that over here as well. But the important thing, let's go back to the first page that I have. When we use the product rule, when we've got something multiplied by something, this is the dy over dx method, and this is the f dash x method. They're both exactly the same, it's just different notation. In the next video, I'm just going to do another example of this, and we'll do a slightly harder one where we've got to mix up the chain rule into the product rule.